I'm going to talk a little bit about inquiry methods, and I'll tell you a little bit about the materials, but I assume this is not a webinar format, right? So maybe you could unmute yourself and just let me know, like, who in the room is familiar with inquiry or who has used it in maybe differential equations, because that would be helpful just to hear a little bit.
I suppose I'll start. I'll admit I've used it in analysis and mathematical reasoning, but not for differential equations. So I'm really curious to see the kind of imagery with that.
Yeah. And if you think about it, some of the other people, I mean, you could just put something in the chat, whatever. I'm sure Terrence could fill me in. But yeah, I was a complete stranger to inquiry. I used a little bit in calculus, but for DE, I thought, man, what is this going to look like? And this is basically a reflection. What I'll share with you is a reflection from having taught the course or with these materials 3 times. And it was definitely a growing process. Like I was much better, say the 3rd or 4th time than it was the 1st time. And I'm at Piedmont, Virginia Community College in Charlottesville. All right. Okay, so I'll talk a little bit about how I see inquiry and just discuss this a little bit. And so these are, I think, the 4 main pillars, right? Is that oftentimes when students have a question, we actually answer it with a question, right? We prompt them a lot, we give them a lot of feedback. I do guide them though, if they are lost at sea, right? I think it's important to kind of guide them back on track because we know the objectives. The second one there is really important, always asking for, okay, you're doing that, but why are you doing it? What's the justification? But I think the one that takes the cake for me is the 3rd one, and that is really listening to your students. And I think this is the hardest part, at least for me, for inquiry, because basically I could not teach the class using inquiry without the students being there. So you're literally using what they produce to actually meet the objectives. And I think the first time for me, that was, it was a terrifying prospect, right? Because you really have to have this trust in your students that they're going to be able to produce this content. And then, of course, we've heard the last one a lot, that they must kind of own the mathematics because you're going to ask them to make presentations and explain the results. So all that good stuff. I'll talk a little bit about what it isn't, right? Because I think the first time I dove into inquiry, I thought it was some of these things, right? Like students sort of being lost at sea, like what am I doing? And sometimes that happens, to be honest. If the task is poorly designed, then that's exactly what will happen, right? So the students sort of miss the point. I've seen some inquiry materials where I would almost call them hand-holding, and that's because they almost look like Mad Libs. So they ask a student to do something and fill this in, then they ask them to do something else. That to me is not inquiry, right? So that's sort of like you're guiding them through a process, but there's nothing that they're exploring. There's nothing novel that they're coming up with. Because there's too much scaffolding, right? So what you'll see in these materials is that there's very little, right? But the teacher has to provide that. And of course, it's not discovering things. And sometimes you will hear this from students, right? The teacher, you know, I take a class where the teacher isn't teaching, right? And that sometimes from our perspective is frustrating, right? It's difficult to hear that sometimes. But I'll share with you, I guess, victories and failures, right? Because inquiry to me is very challenging. And it's definitely something where I don't feel like I'm an expert. All right. So this is what I did for this course. And this is a little bit different than I think what other people who have used the materials did. But this was with the 3rd installment of the course. This is what I found worked very well for me. So I'll provide some context for you, is that my class was broken up into groups of about 3 or 4. And so every class, one student would get a break, right? So they would be the recorder for the day. And so what that meant is they didn't have to participate in the discussion, but they had to document what was happening, right? So they really had to pay attention to who was sharing, what was the objective, what were the students doing. So the first thing I do is I assign a recorder. Everyone has to do it. I did find over time, though, that students would tend to dread this task, like, oh, you've been chosen, the shortest straw has been pulled for you, right? And they'd have to do it. But I'll share with you the type of content that they come up with there. So you have tasks, right? And I'll share a few with you. You give them a task and you make sure they understand what it is that they have to do. And then that's basically it, right? So number 2, the groups start to talk about the task, unpack it, make some sense with what they're being asked to do. I will walk around and mostly listen. I will help them if they're way off base and if they misread something, right? Because I feel like I should just make sure that they're engaging in the correct thing. And near the end of near the end of the class, I'll pick, for example, 2 or 3 groups to share their results with their classmates. And this is a great time where there's some cross discussion. Different groups will contribute and say, wait a minute, we did something pretty similar to that. And they'll want to share their whiteboards. And then basically the teaching is me making connections. So I don't know if anyone in the room has heard of the 5 practices, Smith and Stein. So they use those in K through 12 a lot. And I see inquiry as using a lot of that, where you have to connect the student ideas. So that's really the shape that teaching takes in an inquiry format. It's much less direct instruction and more like, I see these organic ideas. How do I tie them together to the conventions that we know in mathematics so that students can understand what it is that they produced? And then the wonderful thing, number 5, right, is at the end of the class, the recorder will send me their notes, right, their write-up of what happened. And this usually goes through a couple of iterations. So I'll send them back some comments, they'll polish it off, and then I share that record with everyone in the class, right? So it's wonderful, not only because you have a nice record, but it's great for absent students as well, right? So they have a detailed record of this is what happened when I wasn't here, right? So it kind of takes care of that problem as well. But this is something I didn't do right away. It took me a while before I said, you know, this is gonna, I think, work for me in DE. So at any point, if you have any questions, just like totally interrupt. I'm totally fine with that. Okay, and this is something I did the second time I taught DE, is it is shocking to learn by inquiry. So what I found is that my students needed a day where they were just doing something that was inquiry. So I had to sort of introduce to them, this is how we're going to learn differential equations, right? Rather than just jumping right in. So I do this problem. Obviously, I don't call it the 4-color map problem because I don't want to give it away, right? So I call it the map coloring problem. Day 1 of class, we do this, right? So if you look at the task here, you can see that there are things like talk about boundaries and vertices, right? So in other words, I'm asking them to define these things. What does it mean to have a border? What does it mean to have a vertex? And number 2, what does it mean to color a map correctly? Right, so they can come up with these interesting definitions, and this is where the inquiry elements come in, right? Is that we all agree as a class, like, you know what, if you have 2 countries that share a border, we want to color those differently, right? So they kind of they can come up with these definitions that make sense. So you can see 3, 4, and 5. That's where the inquiry is, where the students are thinking about the task. They're drawing lots of pictures. They usually label their pictures with like R, B, Y, right, to indicate the colors, or sometimes they take out their highlighters, right, and they start working with those. But the amazing thing is what happens when they get to 6, right? Everyone in the room, I'm guessing, is familiar with this task. Draw a 5-country map that requires 5 colors. And of course, they can't do it, right? So this is a nice way of saying, like, hey, we have this thing called the 4-color theorem, and this is a way to organically and sort of empirically come up with that result. So I spend the time at the end of the first class doing this problem saying, guess what? We're going to learn differential equations exactly like this, right? So we're going to build, sort of invent some of the vocabulary, build the basic ideas, and then I'm going to ask you to explain to your classmates, right? What did you come up with? What did you find, right? So I found that if I do this first, they're already kind of in that mode and they say, okay, cool. We're going to be asked to contribute and to share what we know. So I hope that makes sense. If you can think of another task that kind of is lively and interesting, but I found this one really does connect pretty well with students, and it has a very low entry point. So anyone can dive in and just do it right away. Okay. So I'll share with you the curriculum. It's not mine, right? So this was years ago. I gave Chris Rasmussen a call, right? So he's at, I think, San Diego State, and he has the IODE materials, and it's inquiry-oriented differential equations. And I had read a lot about his materials on several journal articles. And I said, you know what, I got to contact him because this was long before this website existed. So it was old fashioned. I called him, right? So we set up a phone call and he said, absolutely, I'll share the materials with you. Tell me how it goes, right? So I was using them for years. So anyway, now they're at their house right here. So if you want to get them, I think all you have to do is inquire about them, and they will send you like a zip file or some Dropbox or something. They'll get the materials for you, right? So I think there's a couple that you can just look at that are available, but if you want the whole thing, you do have to ask. But anyway, just so you know, this is what I'm talking about in this session. So I wanted to show you just like a couple of sample tasks, like what do they look like? What makes it different? So here's an example, right? And it looks like simple, like multiple choice, but you can see, I think, when you look at this task, how qualitative it is, right? So they say, here's a couple of vector fields. I'm going to give you 6 rate of change equations, match them up, right? So you could tell that students really have to think about this, right? So they're thinking about the solution curve. Sometimes it will confuse the solution curve with the rate of change, right? And you can see that in some of the selections at the bottom. But problems like this really get students talking, sometimes even arguing with each other, right? So I could tell right away, like, whoa, this is so different than the DE that I'm accustomed to. Like, oh, here's a differential equation, solve it. This is very different. So giving you differential equations and qualitatively like match them up and justify, right? So you really have to explain. So his curriculum is full of these types of materials. Here's another one that honestly, you could, I feel, use this in Calculus 1, right? When you're teaching about derivatives, it's a very rich problem. So it's about memorizing a list, where L is the fraction of the list memorized. So it's just a beautiful problem where students are forced to sort of look at the sign of the derivative. And that's why I think it's great for even Calculus 1, when you talk about rate of change. And there's all those great questions like, you know, suppose you have the list entirely memorized. What does that mean, right? So question C, and then a little bit of directing students to like, you know, will one student ever catch up to the other? So again, this is more than just plugging in numbers. It's lots of explanation, and students tend to write a lot for these and come up with some pretty inventive, novel ways of solving these problems. You can probably guess by looking at these that these take time, right? So that's one of the big things I'll talk about at the end is the sacrifice I make is I absolutely can't get through all the content, right? So I sacrifice it by letting the students have these really rich discussions. But I'm going to share with you some examples of student work, like what do they do with these problems? Because I think that's what you're here for, right? What are they doing? So here's a sample task, one where I'll show you some student work. So you can see this is about a bug population. The reason I like this task, and you will find this in standard DE books, is the graph has the population of bugs on one axis and the rate of change on the other. This is so hard for students, right, to actually make sense of this. And you can see there's reference to previous things in the curriculum. It talks about a cooling coffee problem that we did with data. So anyway, it's the vagueness of the instructions that I love here. It says, describe in words the long-term behavior of each solution corresponding to the below initial conditions. And then it says, illustrate your conclusions with a graph. So you'll notice it doesn't tell you what graph. It doesn't tell you produce the graph of the bug population with respect to time. It doesn't tell you to do that. So it tells you to basically come up with tools that will help you describe what's happening here. And the students, when they did this, they found, or they called the sweet spot in between like 3 and 6, right? Because that's where the slope is positive, right? The population's sort of flourishing there. So I'll show you what the students did. Okay, so this was the work produced by one group. And of course, we're content experts, right? So we totally recognize what the students did, right? So this was pretty awesome. I'll maybe use my mouse pointer. This graph here, where they actually attempted to plot a graph of T and N, and they chose those different starting points. And I love that they used this alternate language, right? So they didn't call them repellers and attractors because they didn't have that jargon. So they just called it, they used a push-pull analogy, right? To actually say, this is what's kind of happening. So anything near 6 gets pulled to that value. Anything sort of under 3, it gets, or anything slightly away from 3, it pushes away, right? And this is sort of the flow line that they produced. And this was before we had talked about it. So as a teacher, I love seeing something like this because when we work with number lines, it's always horizontal, right? But when you see flow lines in books, naturally it's vertical, right? Because it makes sense with the N axis. So this is an opportunity to talk about, like, this is what the students did, but let's look in our book, or let's talk about some of the conventions that we can find in our book. So this is what I feel like is bona fide inquiry, right? Because students will come up with things where it won't look exactly conventional, but they're not necessarily afraid to either make up their terms or just use a tool or a number line to come up with the mathematics. Here's an example of, this was a different year that I did this, where this is what the recorder came up with, right? So I wanted to show you an example of, this was Ashley, where she took notes that day. And you can see it wasn't just the bug task that we did, but another task as well. So these are her notes, these are not mine. And so she talked about, Brower went to the board and he did all of this stuff. And he talked about, you know, based on the initial population, this is what N is approaching. So you can see this day it was different, right? So the students actually have the vertical flow line. So that's the thing, is it's unpredictable, right? So sometimes students will do things that are conventional with textbooks. Other times it looks a little bit different. But I admire Chris, and I told him, because we had a few conversations, I said, these tasks are really good because students produce some really interesting work. And that's because he class tested them many times before releasing them. So I'll show you another one. So this one here is the one probably closest to my heart. I see tasks like this very similar in other DiffyQ books. So this is the fish harvesting task, where they give you a differential equation describing the number of fish. And this you could almost turn into a project, right? It says the hatchery was bought out and they're going to allow fishing, right? So the question here is, how many fish per year should be harvested, right? So this is a good question, because students get really stumped by this, because they're like, well, is there a special number? Like, if we overfish, is that a problem? But they think about things such as bringing the business component in, right? So we want to make money by allowing fishing, but at the same time, we don't want the pond to go completely without fish. So this problem, I'll be frank, this one took the full 75 minutes, right? So this is one where this took the whole class for students to solve, because they were bringing all different types of tools to the problem and trying to come up with a solution. So the one I'll share with you, this is the only time I have seen this, but Chris reported on this as well. I think he wrote a journal article in Primus about this, but this was the only time I saw a group almost invent a bifurcation diagram, right? So not all groups will do this, but this group, if you look at the very top of their work, and keep in mind what I'm showing you here, this is not the only thing they did. They had pages and pages of work, but then at the end, when they wanted to present it to their classmates, they kind of organized it in a nice, clean way, and they took this particular page and showed their work. So what they did initially is they said, you know what, to show the fishing, we're going to have some components, a minus K component here, and we're going to play with K, right? We're going to play around with that value. So they first started with some different values and then asking themselves, what are the units of this value? What does this mean? And then they realized at one point, like, let's just do it for general K. So why are we solving this problem and finding these sort of equilibrium points? Let's just put the K in there and solve it. They used Maple when they did this, and they got 12.5. And then what they did, based on our previous activities, is they lined up the flow lines, right? So they stacked them up along the K axis. And so you can see population on the Y and the K axis on the X. And they talked about what it meant, right, for the values to be inside this parabolic section or outside that parabolic section. So of course, we recognize this as a bifurcation diagram. And so this is something where you can use this as a discussion point in your class. Okay, so I'll talk a little bit about now the dark side, right? Like, this is hard to do. And the data I'm showing you, I'm showing you some of the best stuff, right? These are some of the things from the 3 or 4 years where I taught it, where students will produce this, right? But these are the main barriers, and you'll notice number 1 and number 4, right? Sometimes students don't like this if they're not accustomed to this, and teachers are extremely reluctant, right? to do this if it doesn't go well. I almost quit the first time I used inquiry in DE because it was very, very difficult to do. Time is the main barrier. I told my department chair the first semester, I said, you know what, I'm only going to get through 2/3 of the content. And is that a problem? And she said, well, you have to ask if that's going to be a problem. So that semester, I did have to end up throwing the book at them at the end of the semester because we ran out of time. So when I think about though the experience that the students have, I do think the time working with each other and producing this mathematics is definitely more memorable and more valuable, right, than some of the standard methods of teaching. Assessment is the hardest, right? I put that one in red. So I'll show you a couple of things. When this is happening real time, it's really hard for a teacher to gauge like what group is going to share their work and why, right? So I use a lot of pedagogy methods from K through 12, specifically the 5 practices. And that is like looking at what the students produce and say, does this align with your goal? Does this align with what you want students to know? So that's a difficult thing to do real time, right? What assumptions are they making? And is the math correct? Because sometimes a group wants to present, but their mathematics may be not correct, right? So teachers have to make a lot of on-the-fly decisions, right? Because like I said, you're trusting your students, right, to produce this work. I thought you probably would want to see what do the students say about this. Now this I can tell you is representative across the 3 years. So you can read some of these comments. Most students really enjoy it. They enjoy the experience of sitting alongside someone and sharing in the mathematics. I'm being really honest with you. The second comment is also pretty common. You know, I haven't really gotten the point of this class because they're like, why aren't you feeding me information, right? So why are you making us think? So they will be very honest and share that with you. But if you don't mind indulging me, look at the last comment, right? So this student, PG-13, this is sweet as hell, right? So this is a student where I could clearly tell this was his cup of tea. He was like, I'm so tired of sitting here being told how to do stuff when I can do it myself, right? So he's saying here, you're giving us time to think, I'm not bored. And one of the main things is memory and retention. So when you ask us to do this, I remember it, right? It's not like I forget it a week later. So again, it's not all the students, but it's definitely some students that I noticed that inquiry really connects with them. So I don't know if it's the answer, right, to math education, but it's definitely a proposition, something that works in some classes. So I'll share with you just, of course, the other benefits that are mostly non-mathematical, right? And you know this because I'm doing far less of the talking in a class like this, right? So they do get some of these skills to think outside the box, give presentations, and work in a team setting. And I mentioned this number 6. I can't emphasize this enough. I think some students who did very, very well in my class would have been C students in a standard class. And I think, though, that could be vice versa. You could have a student that, hey, I want the standard environment, traditional instruction, and they might struggle in an inquiry setting. I don't have an answer to that. So I can see some of you nodding, like, I wish I did have an answer to that. How do you deal with that? I don't know, because I feel bad sometimes because this doesn't work for everyone, but nor does traditional instruction, right? So a lot of studies have indicated that. So I figure I'll leave some time for questions, right? Is that okay on time, Terrence?
Yes, we still have about 5 or 6 minutes left. And so if it's okay with you, there are actually a couple of questions in the chat that I wanted to read out.
Oh, absolutely.
And so I think, and please let me know if I'm not getting this first question right. I think the first question was asking about your course, if it was reserved only for math majors or if other STEM students take this course as well.
Yeah, so, well, this was for pretty much anyone who needed DiffyQ. So there were math majors, there were science majors, and there were prospective engineers. So it was for all of them. And I know Chris has an engineering background, so he does keep that in mind in developing the materials. So yeah, it was your standard introductory DE. Did we lose Terrence? All right, so can everyone hear me? Because I'm not getting anything from Terrence. So I was waiting for him. Okay, so, all right, so maybe I was still sharing screen so I can just thumb through these questions. How do you get the students who don't perform well? Yeah, so this is from Elena. I guess I would say, Elena, like I use the same tools in a traditional format, but I do a lot of active learning now, but it's the same tools where you just have to motivate them to participate and that, you know, to contribute, and they'll learn more. So, but I found I have fewer students in this environment that are off task. Like they're usually pretty engaged because they know at the end of the period they're going to be held accountable, right? Because I might say, okay, you guys have some great ideas. I'm going to ask your group to share. So that's a difficult one. Okay, so Cecile. I totally think this is the case. In fact, this might be the solution to the problem, right? Is that inquiry every single day is very hard, but students will tend to appreciate those days. Hi, Terrence, you're back.
Yeah, sorry about that. My computer just literally just turned itself off. And so
yeah, so I just put the chat on the screen and said, okay, I'll just thumb through these because we totally lost you.
Yeah, so sorry about that, but please continue.
No, it's okay, totally fine. So yes, Cecile, I think I agree with this, that maybe a little bit of both, because then that way I don't get so far behind, right? Because inquiry just sucks all of this valuable time. The book, well, the last time I did this, I didn't use the book. I used the IODE material. So that was the book. Let's see what else. That's interesting. What do you do about students who already know a little bit? Yeah, I guess I always wonder about that. Like Calc 1, like you're sitting there like talking about derivatives and they already know it. But I don't know, in DiffyQ, it just rarely, I don't think I've encountered that when I've done inquiry. Like they don't, they're not that familiar with the flow lines or the initial conditions and all that. So I haven't really encountered that. That would be an interesting thought experiment. I don't know what I would do with that. Do I have any previous experience? Before this, absolutely not. I had zero. And that's why I, 2 weeks in, I was like, if this is inquiry, I'm out of here, right? But I promised myself, I said, I'm going to finish these materials. And by the end, I said, you know what? I see a little bit of light here. This might work if I try it again, because I'm going to get better at it. So I gave Chris another call. And this is definitely an evolutionary process. It's slow, and I think you need buy-in. You need to convince yourself, right? You need to give buy-in to yourself. Is it something that you've ever used? No. Okay, so brand new. Yeah, it's a frightening terrain the first time, but I am a huge proponent now of active learning. I do it a lot in my classes, and inquiry is just one facet of active learning. Okay, so Cecile said, yeah, some students have taken the course or studied it before taking it. Gosh, I wish I had your students. That actually is pretty awesome. I think the math you could do in an environment like that would be phenomenal. Yeah, so I'm happy if you, I don't know if we have any more time. This, by the way, is from the first 2 weeks of the semester. We were virtual, and the last thing I taught, can you believe, through Zoom, is that. Can you think of something harder to teach through Zoom? I'm telling you, that was not a highlight of my career. And I haven't erased it, but that was weeks ago I taught. But anyway, any other questions? Because I'm happy to, if I can, answer for you.
Yeah, I think we have time for maybe one more question before we have to stop. Okay, well, if not, Kate, thank you so much for introducing us to inquiry and differential equations. Really appreciate it.
Yep, sure thing. And you can send me an email if you have any questions or anything. I'm one of those. I'll write back. Totally.
Perfect. Well, thank you guys all for coming to our session on practical things that work in the classroom. I think our next set of sessions start at 7 p.m. Eastern Standard Time, and so we look forward to seeing you there. If you're not tapped out on this Friday afternoon. In any case, you guys have a wonderful rest of your day. Once again, Keith, thank you so much. And if Trevor is still in the house, thank you as well for your talk. I hope to see you guys around somewhere.
All right. Bye, everyone.